Hello, my name is Mark Vina, host of the SmartTechCheck podcast. Today's Wednesday, February 26th, 2025. Digital twin technology offers numerous benefits, including enhanced operational efficiency, predictive maintenance, and accelerated time to market. By creating virtual replicas of physical systems, organizations can optimize performance and proactively address issues. DigyCorp's mission is to drive innovation and secure collaboration through cutting-edge digital twin and AI solutions, empowering clients to make informed decisions and achieve meaningful impact across various industries. Joining me for a candid conversation on what DigyCorp is doing in this space is Naeem Atta, the company's founder and CEO. Naeem, welcome to the podcast. How are you?
Hi, Mark. Thanks for having me. I'm great. Thank you. It's a pleasure to be on your podcast.
Oh, glad to have you on. I mean, I have talked about digital twin technology with other clients and other, subject matter experts. It's a subject that mainstream people, I don't really think they've gotten their heads around. If you're in the space like we are, you obviously understand it. But this should be a great discussion, and I appreciate you taking your time up because you're calling in from the UK, if I'm not mistaken, correct?
Yeah, sunny UK, or not so sunny.
I love the UK. I think a mutual friend of us knows that I lived out there for about 6 months years ago when I worked for Compaq, and I went to the theater every night in the West End next to Broadway. The West End has the best theater in the world, so that's my plug. Hold on. Sorry, little interruption there, as it always happens. What I'd like to do before we start the get into the meat of the topics here, I want to talk to you about your background, who you are, and then we'll go into the topics that I'd like to kind of dive into. So this is a couple of minutes for you to kind of discuss who Naeem Atta is.
Yeah, thanks, Mark. I'm a techie at heart, so I've been in the techie space now for about 30 years. So I graduated back in the early 90s. My background is IT, technology, and I started my career as a software developer. Prior to that, my background as my father immigrated to. He was an economic migrant to the UK back in '62. So he moved to the UK, and we come from a subcontinent, fairly humble background. So my father brought us up, drumming into us. It's a very subcontinent thing to do. You must get your studies. You must get good grades and all that. So that all paid off. I did my studies, and I did a BSc and a master's in IT. And then I spent first half of my life coding, really, Mark. And after that, so that was coding for Ministry of Defence, and doing sort of mission critical systems. And that really laid the foundations for my technical background. And I moved from there, I experienced sims or simulators, and that's where my journey on digital twinning started. So that's my background really. And the second half of my life, I've initially moved into data. For a while, I worked for the UK government as their chief data officer for the Intellectual Property Office. So I moved from coding all the way up to executive roles, and I thought, hey, I need to start my own company, right? So I'm enjoying this so much. So then I started DigyCorp, really. So that's a little bit of background about what I've been up to and where I come from.
I appreciate that, and you obviously have the background to get involved in the technology area that we're going to talk about. And let's talk about who DigyCorp is. Let's start there.
Yeah, of course. So DigyCorp was when I was doing work for the defense, and then I moved to the city, and then after that, I formed DigyCorp back in 2015, and it was off the back of my experience, really, on looking at simulations and looking at doing simulations for the Royal Air Force, for their aircraft, for the Harrier aircraft at the moment, which I think has been decommissioned now. And then I moved on to submarines and simulating submarines and submarine attack models. So that was sort of my mission. It was like a mission critical background. And then once digital twinning, as you know, is a phrase that's been coined quite recently. Although the foundations for it has been around for quite a while. So we did quite a bit of work on UK national infrastructure. So we worked with National Grid. We worked with them balancing UK electricity supply and demand. And then so DigyCorp also we looked at digital twinning in the sustainability space. And over the years, we've kind of become a bit of a specialist in digital twinning because of that natural transition background. I'd like to say it was all pre-planned, but as you know, most of these things, you kind of, as you go through and you experience and you see opportunities, we've decided now to focus on sustainability, what we have been doing. Again, that's naturally because there was a time period where I did work for doing wind power forecasting and simulating that and creating a digital twin of the UK wind power stations and trying to predict UK electricity supply.
Right.
So
that's Naeem, the question I want you to jump into real quick before we hit the other topics. I pointed out earlier at the top of the podcast that for the mainstream user, who they're still struggling to get their head around AI and generative AI and the AI avalanche. And give me a 30-second, if you had to describe to someone in an elevator, the infamous elevator pitch of what digital twin technology is. Give me a quick, just 1 minute overview. So for the common person.
Sure. So I always like to use an example, but in essence, there's always the theoretical definition. But let's not go into theoretical definitions. Let's just look at a digital twin is really a sort of a digital representation of any physical environment. And what these days, what's become readily available, a bunch of technologies have come together. So whether it's IoT or sensors, or it's networking, or whether it's compute or storage. So all these things have recently, and AI now, of course, come together. So you take any physical environment and you cover it in sensors, and you feed that information into a platform, and you analyze that, and you say, okay, this is what this physical environment is doing at this moment, and you start streaming live data to it. And in essence, you end up with a digital version of the real thing. And that's effectively a digital twin, really, in its very simple terms. A good example I like to use is back in 1970 when Apollo 13, they had a as you know, there was a problem because they had an explosion in an oxygen tank, and that led to the engine being damaged and so forth. And what they did was they had very sophisticated simulators, and they just streamed that data back to the simulators, and they configured the simulators to be in the same state of damage as the actual aircraft, and then they could manage to practice, how many thrusters do we use and how do we position the aircraft with the new center of gravity and how can we get the aircraft down safely. So they practice on that really before they actually manage to get the guys back home safely. So it's in a way it's really simulating a real world environment.
You know what? That is a fantastic analogy. In fact, the other night I was watching it's a great movie, the movie Sully, about the Sullenberger, the pilot the infamous landing on the Hudson a few years ago.
Yeah.
Good portion of the movie at the end is simulations. And again, I mean, I don't know whether that's accurate or not, but the FAA tried to create a scenario where, after he struck the birds, that he could have landed at another local airport. And there's nothing but simulations over and over again. And these are not, they are obviously live simulations, but they're done in simulators, with other technology. And but I think that's a fantastic. I mean, to me, that you nailed it. I mean, people can wrap their head around that.
Yeah, don't watch Apollo 13.
Right. Oh yeah. No.
For some of the people who are watching, if they don't get it, I think it's a great. Yeah, you're right. It's a great.
Oh yeah. No, that is a terrific example. So let's go. We've been talking about that. Map that, especially the digital component, because that's again where the Apollo 13 analogy kind of diverts, is that was not a digital simulator. That was obviously they had physical simulators, and which are expensive. They're complex. They take a long time to develop. And the great thing about digital capability is that it's all virtual, and much of it is software. Some of it's hardware. but you can create all kinds of interesting digital twin scenarios without building a physical product or a physical capability. So let's talk about that.
Okay, yeah, sure. So this is from our good friends. This is a periodic table from our good friends at the Digital Twin Consortium. They've got a great definition. But rather than going into the definition, if we look at it's kind of you've got a bunch of capabilities, and with these capabilities, more and more addition onto what a digital version is making it so realistic. It's almost lifelike to the real thing. And this here periodic table and main areas here tell us what are the main components of a digital twin, and not always you don't always need all the components to make a digital twin. So depending on the use case, you will look at some of those, and I think it's on maybe it's the next slide. If you look at that, it tells you, based on a particular scenario, you will utilize some of those capabilities, and some of it may be visualization, some of it may be AI, some of it may be data integration. So there's some core components, and there are some additional components. And what it gives you, I think, with a digital twin, you can test before you invest, which is probably a phrase. So if you're with some of these scenarios, if you're looking at, for example, a social housing, you can have a whole bunch of houses, and you can say, okay, I've got all these houses, and I've got all these boilers, and I've got this type of windows, and I've got these type of insulation and things. And if I want to reach my net zero, if I do this, and this, will I reach my net zero? So you kind of it's your crystal ball really into the future. That's what it gives you, and that's what this slide is talking about, really, all the different components and how they come together to create that investment.
Well, and let's talk a little bit about, just make that point on, call it time to market, is that when you, again, in a non-digital twin scenario, building something that's physical takes lots of time, and there's lots of trial and error. And my assumption, and I suspect you can validate my assumption, is that, again, creating a digital twin capability is a lot faster. It's actually a lot more cost effective, and the testing becomes a lot easier, from a reliability standpoint.
Yeah, no, absolutely, Mark. And it allows you to create a virtual environment of something, and some of these things can be quite very costly if you're installing structures in the ocean, or if you're trying to do things. You can save a great deal of investment or divert it to the right channels by doing that digital representation. And then you've got so many layers on top, whether you visualize it. So traditionally we've done quite a bit of work has been done with structures and buildings, but now it's because of the introduction of AI and the introduction of, so you not only do you end up creating a situational awareness of what the physical environment is now, you can also do the what if scenarios, and it starts mimicking the behavior of the actual physical environment, which is something that's not been done in the past. So absolutely.
So again, we've been kind of bouncing around about this. Let's talk about the use cases.
Sure. So okay. So if we look at some of these, the periodic table that you're displaying here, if the idea is the use cases will dictate which of these capabilities you would need for a digital twin. So no two digital twins will be alike, and you can't say you must have X, Y, Z components for it to be. There'll be some foundational stuff, but you don't have to have that. Have specific things. So if we look at the use cases that we're dealing with at DigyCorp, so as I said, in the past, we've done simulations for the military, but more recently, if we look at a couple of our use cases that we're currently working on, one of them is the UK airspace. So we're working with National Air Traffic Services in the UK, and we're trying to create a digital twin of the airspace. So it's you're looking at about it's about 80 million passengers traveling, and it's quite a large number of flights. And if you get all the data from the different sources, whether it's radar data or whether it's air traffic control officers, we're feeding that into a central platform, and the idea is to have a live version of the UK airspace, which actually will be the world's first, actually, because it's not so easy to get all the plumbing right, because one of the key things of these digital twins is getting all the data into the right place. So we're working with National Air Traffic Services. We're hoping to do that sometime by spring and summer this year. So that's an amazing use case, because then you can run, the Air Force, for example, the Royal Air Force might come along and say, okay, we want to fly a jet through the UK's Heathrow airspace. What will that do to the traffic? How will it disrupt it? And then if it disrupts it, how much capacity do we need to open up on surrounding airports to allow for that disruption to be reduced, to be minimized effectively? So that's a great use case at the moment we're working on. We're doing, and NATS are doing some great work, and that's a collaborative effort we're working with them on.
Oh yeah, I mean the defense use models and the military scenarios that this kind of capability can be used is amazing. In terms of being able to test different, hopefully scenarios that don't happen, but allow you to prepare for it. In the United States, for example, non-military, of course, we've had a really terrible rash of airline incidents with.
That's right. Yeah.
We had a situation at Reagan Airport a few weeks ago where a military helicopter crashed into an approaching passenger jet. But we even have problems on the ground, because there's so much traffic on the ground where planes bump into each other. And they have systems to try to avoid that. But again, using this kind of capability, you can very easily, hey, here's how many planes are on the ground. Here's how much traffic. You can kind of project, and you can create scenarios, and and hopefully predict bad things from happening. That's the whole idea of utilizing this capability. It's really fascinating.
Absolutely. And also another great use case is training, really. So if you've got an environment where you can train air traffic control officers on a digital twin, where the aircraft, you've got a live flow, and then you give the air traffic officer control of one of the aircraft, or you give an AI agent. They can do their training on that. So, and that's a great thing, particularly for safety critical systems where you need the training, but to pass the exams, you need to have that exposure to a live environment. So you may as well have exposure to a digital twin environment, which is live. So it's a great value add, and great way of also reducing, increasing safety and reducing costs of training as well.
Sure. Now, this is a bit more, the brick and mortar part of the discussion. Let's talk about the deployment capability and how digital twin technology is deployed. Provide some color on this for me.
Yeah, sure. So typically, what you is it's sort of you always start off with any IT solution by going to the business saying, what problem is it we're trying to solve, and what is it that you need to do? So there's always the traditional, gather the requirements to make sure that are we monitoring only? Are we trying to do predictive analytics? Are we so for example, for agriculture, are we trying to optimize the farming output, or are we simply processing raw materials? Or is it simply for training? So one of the people I was talking to in NEOM, where in Saudi Arabia, where they're doing quite a bit of work on renewable energy, and they're also doing hydrogen. They've got the world's largest hydrogen plant. And they were saying, we need our guys to come in and start training on how to utilize this space in a safe way. And if you create as a digital twin, that would go a long way. So once you get the use case, then you say, okay, based on that, you need some kind of a sensor strategy. What kind of sensors do you need? And sensors are so cheap now and so accurate. Your phone has so many sensors now. So what's your sensor strategy? What is it that you need to measure? And the more you measure, and sometimes you don't know, so you need to have almost sort of a greedy strategy towards measuring what your sensors are going to be. So you place those sensors on a physical object and you say, okay, let's pull that data back to some kind of a central platform. So I remember back in the mid 2000s, early 2000s, everybody was talking about the big data platforms, and so you need to some kind of a big data platform where you pull all this live streaming data in, and you process it and you make sure it's fit for purpose. And on top of that, you then, once that gives you your sort of monitoring and your insights and the situational awareness of what's currently going on in that environment, and then you can start saying, okay, well, let's use some algorithms here, whether it's AI or whether it's statistical learning or machine learning, and let's try to create some behavior of what the physical environment is doing. Once you've done that, then you've got your digital object of the physical environment. And then there's a feedback loop, right, Mark? So once you've got your digital object and you say, okay, you do your what if scenarios and you think, okay, based on this, what I need to be doing is, if it's a kelp forest you're trying to preserve or trying to increase the growth of, you might say, okay, based on the hydrodynamics or based on certain environmental factors, I think that we need to plant more of the kelp forest or seagrass or whatever it is that you're trying in a particular physical place. So then the feedback loop is you change the physical object to be optimized, and then the loop continues, and effectively you end up with a sort of an ongoing a live system where the digital environment, the physical is informing the digital, and the digital is optimizing, and then it's changing you're changing the physical object based on feedback you get from the digital.
Right. Now, in the few minutes we have left here, let's talk about some examples, and maybe in color. There's all kinds of usage models. I mean, we've established that. Talk to me about, as you go through a few of these, because we only have about 2 or 3 minutes left here, about what, as you look at your pipeline in terms of the most popular use model that just seems to be cropping up. I mean, obviously this technology deployed in a lot of different areas, but maybe highlight the 2 or 3 top areas that you're seeing a lot of energy and interest in.
Sure. So we've got some rather unusual. We're fortunate we've got some rather unusual and special use cases. But if we look at traditionally digital twinning, it started off is very strong in the manufacturing space. It's very strong in the Industry 4.0. So typically within manufacturing, so where we are seeing quite a significant amount of interest at the moment is in areas of say buildings or any physical buildings. So BIM and simulating a building and optimizing buildings for not just for energy consumption, but also for the way they're designed and the way they lay out, and how do you optimize that physical space. But more and more we're seeing all sorts of use cases now, really. So we specialize in sustainability and in ecology. So from our perspective, I see, if I look at the future, I see digital twinning almost becoming a part of every system. At the moment, there's a bit of a hype cycle on it, and digital twins. Everybody wants. I need a digital twin, but so I see them at when we talk about things, as I mentioned, the big data platform appeared, and everybody's talking about. But then it just became the norm, and then IoT was a big thing. I don't know if you remember, and then that became the norm. So digital twins are a big thing at the moment, and they're getting a lot of, and rightly so, they're getting a lot of attention because they do some good stuff. But eventually, I think they will become part of the standard things. And if I look at the areas that we're particularly working on, so I mentioned the UK airspace, so that's in collaboration with partners. We're looking at that. Also, in collaboration with the other partners, we're also doing the digital solution for a coral reef restoration in the Red Sea. So we're working with Kaus King Abdullah University Institute of Science and Technology, and they're doing some absolutely amazing work. They've got an incredible mission of over the next 4 or 5 years to plant I think it's about 2 million corals, which is on an industrial scale, because
right.
because just their nursery, ex situ nursery is about the size of 5 football grounds. So that it's sort of Amazon warehouse kind of work. And we're creating together. We're creating a digital twin where you can start looking at monitoring to start with. Okay, so these corals were planted in this environment, and how they're doing. Is there disease? Are they happy? Are they growing at a good rate? And over time, the idea is to create the right monitor the behavior up to a certain point where you can start predicting, okay, these corals with these genome sequences, with this type of environmental factors that they came from, would be ideally positioned to go in this part of the Red Sea, because they're covering about 100 hectares. So the ultimate will be, typically the what if is what now is currently what their monitoring is, and then what if and what next scenarios is what they want to be able to do. And so that's an amazing project. So it's quite unusual. Other things I'd be looking at, so any environment where you want to optimize it. So we on our trip to NEOM, we met up with there's an immense amount of innovative work going on in the Kingdom of Saudi Arabia, and NEOM is sort of the city where part of the Saudi 2030 vision. They're looking for sustainability at the core of the work they do, and we're looking at vertical farming. How do you create vertical farms that are optimized in terms of the water environments and what the composition of the water is like, and what the UV light is. So all those factors, over time you gather data and you learn from that. And as I mentioned, hydrogen plants, that's another area, and also agriculture. How do you optimize? Going forward, we just want for food security. How do you get the maximum of output from this any environment where you're planting, and minimizing usage of resources. So you're trying to do things in a much more sustainable way. So things are much more optimized.
Now, this is fascinating stuff, Naeem. I wish we had more time to jump into this. I'm sure we'll have you again on the podcast at some point, but really fascinating stuff. And I really do appreciate your time to join me for today's podcast. For our viewing and listening audience, thanks for making the Smart Tech Check podcast part of your day or commute. Please make sure that you hit the like and subscribe buttons at the end of today's podcast, or use these on-screen QR codes to connect with me. You can also follow me on X at Mark Vina Tech Guy. And until next time, have a great week. And Naeem, thanks again for your time.
Thanks, Mark. Thanks for having me.
Sure.